Assalamualaikum and hi everyone. My name is Nur Sabrina. I'm from Group 4. So in this video, my friend and I will explain about a saponification of fat where we can see through a soup productions. But before that, I will explain first about the soup and also the method used to determine the component in the soup. So let's go. Soups are made from fats, oils, or fatty acids, which have cleansing properties in water. The common process of making soup is saponification, in which triglycerides present in fats and oils will react with alkalis, such as sodium hydroxide or potassium hydroxide, in order to form soup and glycerol. If sodium hydroxide is used as alkali, the soup form is called hard soup and is used as washing soup. In the other hand, if potassium hydroxide is used as alkali, the soup form is soft soup and is used in some liquid hand soaps and also shaving creams. Therefore, the objective of saponification process in this experiment is to synthesize a sample of hard soup and to test the soup produced. After obtaining the soup, it will be analyzed using FTIR, which is stand for Fourier Transform Infrared Spectrometer. It is used to measure the absorption of infrared radiation by the sample materials versus the wavelength. The infrared absorption bands identify the molecular component and also the structure. Then, FTIR will produce the information of the basis chemical composition and also the physical state of the whole sample. So, in this experiment, the components in the soup are determined by using the FTIR.
Moving on to the methodology of the salt preparation. The preparation of sodium hydroxide was started by 0.25 grams sodium hydroxide will dissolve in the mixture of 1 ml distilled water and 1 ml of 90% ethanol. Then the mixture was heated in the water bed of 100 degrees Celsius. The flask must cover with the aluminium foil to help reduce the evaporation, and the flask must swirl for every few minutes. Next, 4 ml of sodium chloride was placed in the 15 ml beaker and saponification mixture was moved from flask to the beaker, and the mixture was stirred in the ice water bath. The prepared soap on the huge funnel was collected and the ice cold distilled water was added to remove the excess sodium hydroxide. After that, 0.01 gram was removed from the filter paper and was placed in the clean 10 ml graduate cylinder. After that, 0.5 gram of trisodium phosphate was added. The solution was shaken for 50 seconds. Lastly, FTIR analysis are conducted. Next, I will explain about the result and analysis that we got from the FTIR. So this is the graph that we have been obtained from the FTIR analysis. It can be seen that they have a 9 peak, which is the spectrum, which consists from the 500 wave number until the 4000 wave numbers. So based on the IR spectrum table, there are 6 types of the possible compound type that we can found in the soap, which is first is ester, next is imine or oxide, aldehyde, 2-alkane, and the last is alcohol.
Hi, this is Hafiq, and I would like to discuss about the results and findings that we obtained from this experiment. So let's go.
The objective of the experiment is to synthesize a sample of hard soap and also to test the soap produced to see how it reacts with other substances and also to check whether what component does it present in there using the FTIR spectroscopy. First of all, during the analysis of data, we remove about 0.0.1 gram of soap from the filter paper and place it in a clean 10 ml of graduated cylinder. Then we add 3 ml of distilled water and mix both of it, and while closing the lid with the thumb, we'll shake the mixture about 50 seconds vigorously, and after about 30 seconds standing still, the observation that we have recorded is that foam has presence inside the mixture. This indicates that the mixture is a soap. Next, we add 5 to 10 drops of 4% calcium chloride solution to the soap mixture from a pressed pipette. The mixture is shaken for 50 seconds and be stand for about 30 seconds. After the 30 seconds, the observation that we have recorded is that the mixture has turned cloudy. When calcium chloride is mixed with the soap sample, it disturbs the cleansing property that soap has. In this case, salt has the opposite effect of cleansing because it forms the chloride with water, and it also increases the hardness of water. With hard water, the soluble soap forms insoluble salts that block its cleansing properties. Therefore, it decreases the foam level. This does not happen with water because since soap is made from sodium and potassium salts, which are soluble in water. Hard water contains calcium chloride, which has positive charge. When these interact with soap, which have a negative charge, the two of them bond together, creating no charge. Soap molecules have negative charge on one end, and when one of the ends mixes with the blood or the fat, the negative charge and have ability to dissolve in water. Next, we add about 0.5 gram of trisodium phosphate and shake the mixture again for 15 seconds. After allow it to stand for 30 seconds, the observation that we have recorded is the precipitate is formed on the surface of the mixture. Trisodium phosphate is knownly to be highly soluble in water, and this makes calcium chloride ion to precipitate. Today, phosphate are known as water softeners. The same theory applies to detergent, as well as detergent has cleansing properties as well. Next, after the analysis of data, we take a few samples of the soap to be taken to the FTIR. FTIR is short for Fourier Transform Infrared Spectroscopy. It is a technique used to obtain an infrared spectrum of an absorption or emission of a solid, liquid, or gas. It is also a method of analysis based on the interaction, absorption, or production of light by matter. Also may include the interaction of electrons, ions, or acoustic with matter. These are the results obtained from the FTIR process. This region is known as the IR absorption range, where we can divide into a few regions where it has bonds to H, triple bonds, double bonds, and single bonds. The single bonds region are known as the fingerprint region. The fingerprint region is located at near 1500 wavelength and below. How to interpret the IR spectrum? First, we locate where the fingerprint region, and then we check the peak of others other than the fingerprint region. From there, we can see a broad, medium, length, and also a few others. To simplify this, we tabulate the data, and the possible compound type that has been analyzed is ester, imine or oxide, aldehyde, alkane, and also alcohol. This preparation of soap is called saponification process, where ester saponification is a hydrolysis reaction under basic condition. Rather than carboxylic acid, the acid salt is produced. Thus, we can conclude that the compound that are present is carboxylic acid salt, as per shown in the diagram. From this, we can conclude that the objective of the experiment has been achieved successfully.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Rafi bin Ismail and I come from Group 4. So today, I would like to share about the conclusion and the recommendation from my group about the saponification reaction of fat. Let's go. The objective in this experiment was to synthesize a sample of hard soap and test the soap produced, which has been successfully achieved throughout this experiment. Saponification is basically defined as the hydrolysis of an ester under basic condition to form an alcohol and the salt of carboxylic acid as the hydrolysis of the ester linkage between fatty acids and glycerol. In the result and data section, the soap that formed was added with 3 ml distilled water and the white form of 4.2 ml appears after shaken well. Next, the mixture in number 1 was added with 5 to 10 drops of 4% calcium chloride. After the mixture was shaken, white precipitate was formed at the bottom of solution. This occurs as a consequence of that the soap does not react well in hard water as it contains cation of calcium in the solution. After that, 0.5 gram of trisodium phosphate was added into the mixture number 2. The mixture is then turned into a cloudy mixture under the graduate cylinder after the mixture was shaken well. This occurs as the trisodium phosphate acts as a water softener that helps to not affect the cleaning process so that the soap molecule will not react with calcium ion. In order to obtain a promising result, it is crucial to make sure that the sodium hydroxide will dissolve completely in the mixture during the preparation of NaOH so that there was no granules left during the experiment. Next, ensure that all of the measurements are precisely measured, especially when using mass balance, as it is very sensitive, so that the result obtained were nearly the same as the theoretical result. It is also important to make sure that the fat and NaO solution is completely hardened and becomes a whitish paste as it is desired product, which is a soap. Lastly, it is necessary for the mixture of fat and NaOH to be stirred thoroughly during the heating process in order to precipitate out of the soap in solid form.